You guys can start.
Good evening, everyone. I, Shivangi, on behalf of Society for Data Science, BIT Mesra, welcomes you all for our today's session. As you know, we, Society for Data Science, BIT Mesra, a student body of data science enthusiasts, with the aim of bringing more and more students an opportunity to explore and learn about data science. We are delighted to host Data Summit 2022 this year as well. In today's session, we have Ms. Smriti Mishra ma'am with us, Head of Artificial Intelligence at Earth Bank. Ms. Smriti Mishra ma'am is Director at AI for Diversity as well as very well-renowned AI speaker. She is a data scientist at Cattleson and Partners as well as founding members at AI Guild. Today, she will be sharing the insights of data science and artificial intelligence with us. Over to you, ma'am.
Thank you so much for the introduction, Shivangi. It's really nice to be here. And thank you for the invitation from Society of Data Science and DPhi for the partnership and for making this event come together. It's really amazing being here. So, as you know, I'm Smriti, and hopefully, we'll spend the next 90 minutes together discussing data science and artificial intelligence and machine learning and all these awesome technologies. So, during the session, I will begin with some fundamentals of artificial intelligence and data science, and then we'll do a little analytical experiment. And then I'll discuss the roadmap to data science, especially, and like loose roadmap to artificial intelligence as well, and the current state of artificial intelligence. We'll also discuss how to look for a master's or to further study in this field if that's something that's interesting, and how to locate jobs or internships in this domain, how to leverage LinkedIn or social media to get interesting opportunities in this field, and how to be visible. And if someone's interested in being a part of speaking events, how to do that, and how to get more involved in community learning, and what's the importance of community learning when it comes to this domain. And if people are interested and if we have time, I could or I would be happy to share more about some projects that I have personally done. And of course, we'll have a lot of time for Q&A because that's my priority. So the thing is that I'm hoping the session to be extremely interactive as possible. So whoever is there in the stream right now who's joined as a participant, feel free to write your name, introduce yourself in the chat section, or anything that you want to say, discuss, ask. I unfortunately won't be speak to you directly today because that's how StreamYard works. But I'm hoping that we could interact through the chat. So please feel free to write who you are and what you're doing, and if there's maybe some particular domain that you're interested in, or if there's a particular application in artificial intelligence that you find fascinating, feel free to write anything in the chat. So so do I have access to the chat? Like, would I be able to see if someone um, enters something in the chat?
Yeah, it is on the chat comment section. If you check the StreamYard, then it is on the comment section.
Aha, okay. So I spoke a lot and my voice is gone. But yeah, I was in the private chat section and I was like, whoa, okay, why is no one typing? But yeah, it's good to see that there's people in the comment section. So so I have been introduced briefly. I currently am the head of artificial intelligence at Earth Bank. And you feel free to introduce yourself in the chat section also. And that's the reason I'm giving my introduction, so that I can get to know you a little better as well. Yeah, we'll discuss the roadmap soon. So I have been working towards using deep learning, computer vision, image processing to analyze the amount of carbon that's being sequestered or stored in a particular biodiversity using artificial intelligence and deep learning at Earth Bank. And I'm also director at AI for Diversity, which is the world's largest nonprofit initiative which engages and educates different communities and promotes diversity within artificial intelligence. Because the lack of diversity, the lack of inclusiveness, it's a huge problem when it comes to artificial intelligence. I also worked as a data scientist on a medical case to save Swiss government's money by deploying some projects for in shoulder arthroplasty to see if the operation should be performed or not, which was done using some minimal data. So I also worked as a researcher in the field of computational neuroscience at KDH, Royal Institute of Technology, to see how people lose memory in the human brain, etc. And currently, I'm a mentor at Google Women Developer Academy, where I'm mentoring right now for women in technology and career aspects. As a person, I love traveling, I love shooting, and I would definitely want to learn pottery someday. So, on that note, we could probably get started with today's discussions around artificial intelligence and deep learning. So, the first thing that I would like to ask you is what comes to your mind when you hear the words artificial intelligence? So, yeah, like what do you think of? What do you think artificial intelligence is? If I ask you to explain artificial intelligence in simplest words possible, what would you describe it as? So feel free to write that in the comment section, and I'm continuously reading it. Okay, so we have some answers which are interesting. One answer is recommendation system. Definitely artificial intelligence. Human feelings, that's really good. Rational decision making by machine. Automations. Next gen technology, perhaps. Yes. All that are good. I'm not able to share my screen. Just a second. I'll try to share my screen, and in the meantime, I'll just try to share my screen if I can't add things to the stream. In that case, just let me know when you're able to see my screen. Can you see my screen now? The problem is that, can you see my screen now? The problem is that if I share my screen, then I can't access the chat. So can someone help me with that? Just a second. Because I want this to be interactive, and for that I need some of my slides. Oh, okay. So would it be possible to? Oh, that's awesome. Let me see now. I'm so sorry for this. Okay, so I'll try to share it directly now. Let me know when my screen is visible, please. Yes, okay. So can you see my slides now? Awesome. Okay, so we have discussed what comes to your mind when you think of artificial intelligence, and I'm so sorry about this issue. So AI is something that highest level of Neuralink can achieve. Yes. But what is AI at the simplest form? So when you think of artificial intelligence, all these are good examples. Yes. But in its simplest form, artificial intelligence is a machine which is trying to basically mimic human behavior in some way or the other. So in this case, basically AI wants to make the user experience similar to interacting with a human, and that's the whole point of artificial intelligence, or the point behind artificial intelligence. And in this case, the input that goes into the system is a lot of data, like a huge amount of data. We have reams of information and data which we are continuously processing, and the output is the human part, the human behavior part, or the mimicking human brain part. So that is the output of artificial intelligence. So that said, what do you think is the difference between artificial intelligence and human intelligence? Like, when you think of a machine doing something and when you think of you doing something, what are some things that you think you are better at as opposed to the machine? And some things machine would be better at as compared to how we think as humans. Yeah, AI combines CS and robust data sets to enable problem solving. Definitely. The ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require. Yeah, that's all that. It's amazing. Really good answers. So yes, efficiency is a very important point when it comes to comparing human intelligence and artificial intelligence. So I like to think of it in three different ways, or I would like to consider three different points. Emotional decisions are better taken by a human brain, definitely. So, and that was one of the things that I was going to mention when I said 3 points. So, one is decision making ability. So, artificial intelligence is profoundly objective in nature, in choice making, etc. So, it basically analyzes a situation based on only the information that's been given to it at that particular point of time. The next thing is when we look at human brain, it's more subjective, which definitely includes emotional decisions. And there's this part of artificial intelligence which is artificial empathy. So that's something that artificial intelligence hasn't been able to do that well at yet, and this is one of the reasons. When you look at the pace or efficiency, like rate, then artificial intelligence is obviously a lot faster than us, and we cannot beat the speed of AI. The next thing that I like to think of it as is versatility. So, artificial intelligence, it can perform, less assignments in the same amount of time because it can only work on one problem at a time. But we as humans, we're always multitasking. So these are probably some of the key differences. Remembering information, that's a very nice point, and that's something I worked on when I was doing my bachelor thesis in Stockholm. So we used recurrent neural networks and long short-term memories because these neural networks, they can store some memory, obviously not close to the human brain. So there's a lot of work that's been going on in that field, but we're still, too far from very good, strong artificial intelligence. So, are you guys? I'm just gonna walk through the first 10-15 minutes to the fundamentals, and then we'll jump into like some more advanced things. So, are you guys aware of machine learning and deep learning in general? And if you have something you want to share around what your understanding is of machine learning and deep learning, feel free to write that in the chat as well. Or if you have some example that you think is very fascinating, and what according to you is the difference between the two, or yeah, anything you want to share about it. Okay, so yeah, this is like how the taxonomy of, okay, it's good that you've started with machine learning, and I'll share a little bit about deep learning. That's not the focus, but yes, ML is a subset of AI. There are three types of machine learning algorithms: supervised, unsupervised, reinforcement. Yes. Basically, this is the taxonomy of artificial intelligence. So there's AI, which is this huge bucket, and then inside artificial intelligence, you have machine learning, which is not brain inspired. So basically, what happens in machine learning is that you have a system which receives certain input and it produces some output. So in machine learning, you sorry, I spoke a lot. I'll keep repeating that. So in machine learning, you know the input and you know the output, and basically your system wants to use your input or wants to train your input to get as close as possible to the optimal output that you have. Like if you look at this example of, like you have this maybe a graph on which you have a diagonal line, so, and you know that you want to get close to that line. So you would try everything you can to get as close to it as possible. That's how machine learning works. There's not any real learning that happens in machine learning. It's basically just making iterations, just trying to do the same thing over and over and over to be as close to the optimal output as possible. Whereas in deep learning, you have hidden layers. You can code those layers to what you want your model to learn and achieve. It's more brain inspired. So here in blue, you can see the brain inspired parts of artificial intelligence. So the NN, it's neural network. So anything that's basically neural networks or the neurons, they're directly very inspired with the neurons in the human brain. So it's very linked to computational neuroscience in that way. So and then you utilize those neural networks in deep learning. So there are some deep learning algorithms like convolutional neural network, recurrent neural networks, which are basically some layer of neural networks with different activation functions, different mathematical formula that you code to do what you want to achieve. And then there's spiking neural networks, which are the most brain inspired or the closest to the brain. It works very similar to how the signals in our human brain they work in general. So, when it comes to artificial intelligence and data science, they are a little different, but still they have a lot of correlation. And we'll look into this a little bit further in the session as well. But yeah, what do you think, according to you, is the difference or the correlation between the same? So basically, as simple in like simplest words, data science is making sense of the data. Data science is actually not a subset of AI. Data science is a different field in itself, but it has a lot of overlapping happening with artificial intelligence, machine learning, and deep learning. So as you can see in the image that I've put up here, so basically data science in simplest words is to make sense out of the data. Right now we live in this world where there is a lot of data produced each and every day, and we want to utilize that data to get better information, better insights about how we can like make profits in business or have a healthier lifestyle. So exactly, this is probably one of the best definitions that I've come across. Data science is more about analyzing data and make decisions out of it. Um, and whereas like in artificial intelligence you use data to make decisions, but in artificial intelligence you actually learn from your model to make decisions. But in data science you don't like learn from your model, you use that data to get insights out of it, and which eventually helps you to make better decisions, smarter decisions. So in data science, your output is the insight, and in artificial intelligence, you get this learning out of it. You can train your model to do something. So that's the difference between the two. And but you use, like, in order to get insights from the data, you all use some machine learning algorithms, some deep learning algorithms. So that's why there's this overlap happening. So next, we're doing a little experiment. So I would like everyone to be very proactive, as you have been already in this session. So yeah, so choose a problem, any problem that fascinates you. So right now, do not think about artificial intelligence at all. Just select a problem that is interesting to you, some problem that you would like to solve. um, I could give an example. So the problem I want to solve is I want to reduce plastics in the ocean, for example. So I'll give you a minute or two here. So think of a problem and write it down in the chat, or if you don't want to share it in the chat, you can just write it on a piece of paper or just keep it in your mind. But I would recommend writing it down somewhere because it'll help in this 5-minute exercise. So yeah, just a problem that you would like to solve, something that you see around yourself and you that's been bothering you and you want to get rid of that problem somehow. And if there's a question around what problem to select or anything, feel free to write that as well in the chat. So we have the first problem, which is enroachment of roads by vendors. Maybe interesting problem. Cleaning the polluted rivers in India, very close to what I selected, which was reducing plastic in oceans. Very interesting. Obviously, a very important problem. Identify daily employees' feelings and reactions without involving them. That's also very interesting. So we'll maybe wait for a minute until most people get back with the problems that they have identified to work with. Reducing screen time, I think that's very important right now. Controlling accidents in traffic, definitely a very interesting problem. I think technology can help a lot in, working with accidents and controlling traffic a lot better than it is right now. Identifying monuments from satellite images. Oh, that's a very interesting problem. That's something similar to what I have been working at my day job at Earth Bank. I don't understand what that is. VUM.NGO. If you could please elaborate. So yeah, I think we have most people who have identified a problem at this point. Improving healthcare, definitely. Reducing open defecation in Nigeria by analyzing the number of public toilets. Oh, that's a very interesting problem. Thank you for sharing. So now, once you have maybe selected a problem that you that fascinates you or something that you want to work towards, the next thing we would like to look at is if your problem has a computational side to it. So now you have a problem, um, and basically a computational side would be spreading awareness in remote areas, villages. That's a very interesting problem and something that I could use to explain my this next part as well. So yeah, you can keep writing about the problem that you have identified, and we'll discuss this as well in the meantime. So once you have identified the problem that you want to work with, we need to see if the problem that we have selected has a computational side. So usually, when you come up with a problem, it's It could be because, because it bothers me to see that the oceans are polluted, for example, and I don't want that happening. So that comes from maybe a more emotional or a logical place, right? So you have the sense of theory attached to it that that this has been happening. But in order to solve a problem, we need to analyze why it's happening, and to go to that why, um, it can actually have two different sides. So it can have a descriptive side, which is like the more theoretical aspects, and then a more computational side. So basically, a computational problem is a problem which can be solved using an algorithm, in simple words. So, and a computational problem can be of different types. So it can be a decision problem or a search problem or optimization or quantification, counting, like it could be anything. So now when you have identified your problem, we need to see if we can, find a computational side to our problem. So if you look at the problem I chose earlier, we see that we have to separate plastic from other objects that's there. So, in order to do that, it's clearly a classification problem. We are segregating two objects, and we'll also get, the amount of plastic that's being, like we'll get some estimation around the amount or the measure of plastic pollutants that's there in the ocean or the water body. So it's also a quantification or counting problem. So that is the computational side that's attached to the problem that I'm working with. Yeah, working with cancer in early stage, that's also a very, very important problem. So yeah, this step is extremely crucial because it helps you understand the nature of your input, and what sort of expected output, like what is the nature of your expected output. So yeah, like analyze your problems and see if there is like maybe some computational side to your problem that you can link it to. So I'll just give like 2 minutes again here to, so that you can think about it a little. And if there is something you can find, feel free to write that in the chat, or just say that you have found a computational side, or if you have any questions around that, feel free to ask that as well. I don't think that it's possible to, at least at this point, based on the progress that we have done in artificial intelligence right now, to make human clones which could possibly live longer than humans right now, it would go a long way. Yes, definitely. A smoother public transport has a computational side. The other problem that we got from Mayuk was preventing certain species of animal from extinction. So if we look at that problem, for example, that clearly has a computational side, right? Um, we need to see the amount of, like, we need to see the number of animals, like we need to, so that involves some sort of counting that could possibly involve some sort of search or decision aspects as well. So yeah. So does anyone want to share anything, or should we just move to the next slide? Just write that in the chat. I identify daily employees' problems from React and reactions. Yes, that also has a computational side, definitely. So I'm hoping that most of you have figured out a computational side, or if it has a computational side. to the problem or not. So so we'll go to the next part, which is if you find a computational site, we need to see if the computational site that we have discovered, it follows a known logic. So by this, what I mean is we need to actually understand that the computational side that we discovered, um, we need to do like a more theoretical analysis of that, of what we have right now, what would be the nature of, what would be the factors that our computation would depend on, what would be the key parameters that we need to consider in order to solve a problem. So we're not necessarily diving into artificial intelligence yet, but it's a good foundation to understand how we can approach a problem. So if we look at the problem that I selected, for example, the ocean plastic problem, which I selected earlier, I would think of the information of what information I would require in order to analyze plastic in the ocean. So I will need some satellite images. I would probably need someone to buy a GoPro and dive underwater, get underwater images. And so, yes, I would basically need to analyze all of those images, perform some segmentation, perform a lot of different techniques on it. So, but yeah, I can think of my computational side following a known logic. So just analyze your problem in the same way right now. And I'll go through some comments in the meantime. Yes, so Anubhav Thakur writes about the enroachment part of the problem, that we need to look at the initial size allocated, current width of the road, hotspots, etc. Like we can get the percentage of enroachments which are permanent and temporary. So that's like a very good analysis of the computational side to a problem. So although you're not yet diving into artificial intelligence, this already does a lot of job for you, and this gives you a very good understanding of what your input, what your output is going to be based on those 5-6 factors that he's mentioned right now. So this is where we, like in this third step, is where we see if what we have discovered follows a known logic. So once you think that what you have done until now, it already follows a known logic, is yeah, it's when now you know that it follows known logic. So this is when you can probably start thinking about artificial intelligence. So now with that logic that you already have, how do we solve the problem? So in the example that I discussed earlier, we saw that I could use some satellite images or some other type of different types of images and analyze them to get to understand more about the plastic in the water bodies and oceans or rivers or anything. So so this basically, in the last step, it tells me that following the logic, that I could use some object detection, image processing, image segmentation, augmentation techniques, computer vision, and essentially some sophisticated algorithms like convolutional neural networks, which are amazing for object detection, and a lot of amazing applications are there for CNNs. So so now you have until this point, you have a very good understanding, and now you can actually dive into more of like productionalizing the model that you're building. You can think about what data you can afford to buy based on the budget that you have, or what data can you collect in the time that you have. What's your deadline, what's the production cost, what's going to be, who are the people that you're working with, and what's their expertise. If I'm working with someone who's probably an expert in recurrent neural networks, I can't really go ahead and work on a complete CNN based model. I would need some expertise around that. And once you have discussed or decided all of that, you can proceed further to collect the data and analyze it in the same way. So now you have collected this data, you already know what factors are the most important for you. And once you have already come across or decided what features you want to proceed with, then you can already, like, do some feature and okay, those are some parts that we'll discuss right after this. So I'll just stop it here. So basically, once you get the data, we need to clean it. We need to prepare a data set that's, that can be used on the data that you have achieved, and then after that we work on the algorithm part. So this was basically how I think is the best way to approach a problem. A lot of people, right when they see the problem, they start thinking of, oh, okay, so I can use convolutional neural networks on this model. But honestly, I don't think that's the best way to approach it, because in my opinion, the entire concept of artificial intelligence is derived from the human brain. So we first need to analyze it as humans, understand the problem associated with it, and after that we need to like work more on the computing or the computational, the algorithm parts. So I hope this quick experiment was useful. So now I would like to move on to the roadmap of data science and AI. So if you have ever Googled the roadmap to data science and AI, it'll probably show you a list of, like, I don't know, 20, 30 skills. Yeah, please feel free to write that out in the chat section. And okay, I'll just very quickly go through the chat again. I think I missed a couple of messages. Yeah, happiness index, or some things that could be used as, how they are, what type of music are they listening to, for example, um, like, and you don't want to use the person's data, I think, for analysis, but otherwise a very good way to analyze that would be, how a person is texting. So if you work with mental health, for example, and someone uses the word suicide, or but if someone uses the a crying face emoji, for example, because we use emojis a lot right now. So if someone uses a crying face emoji, they are like a lot more frequently. That's probably like a 19-20% better indicator of someone who's suicidal, as opposed to using the actual word suicide. But if you don't want to collect the person's data and use it, then yeah, happiness index could be a very interesting way to look at it. And yeah, that's a very interesting aspect. And also, like, analyzing what kind of you know um, what kind of music, or what kind of like television shows or such things they're associating themselves with, which is not necessarily collecting a lot of their personal data. That's a lot of data that's already being collected, and we are like using it continuously. So yeah, so maybe something around that. Yeah, so if you look at the roadmap to data science and AI, there are so many prerequisites that show up. It's like foundation of computer science, um, mathematics, statistics, programming, data storage, pipelines, data wrangling, GitHub, collaborative coding, Docker, APIs, frameworks. I don't know. It's a lot. Distributive computing, and it can sometimes honestly be a little overwhelming. So I'll try to simplify it a little. So I'll go through this pyramid. So basically, this is sort of like the strata, the pyramid that I would like to share with you. So here we'll start from the bottom and we'll walk our way up the pyramid. So as you can see, the ones on the bottom are the most wide ones. They're the ones that's most commonly used. And as it keeps getting skinnier at the top, or as it keeps going up, that's when the complexity increases, and those are the things that's not the most used as opposed to the others on the bottom. So we'll analyze this pyramid. So this is more focused on this is like a more focused roadmap to data science as opposed to general artificial intelligence. So as a data scientist, you need to know programming, or you need to have expertise in programming in at least one language. So I mostly work with Python, and it is good to know common data structures, having an understanding of how basic algorithms work, how to work with external libraries, frameworks, APIs. And the other thing that's extremely important is SQL. So scripting comes in very handy if you know SQL already, because it helps you actually get the data in the real world. And if you need data to analyze, right, and if you don't have any data, it's not really, yeah, I'll share the slides. It's not really possible to analyze anything at all. So yeah, SQL is very important. And the other thing that I recommend everyone investing some time in is using GitHub, because you'll always work in teams, and it's nice to know version control and get the next thing that we see on top of programming is data collection, extraction, data wrangling. So this is extremely important because often the data that you receive, it'll never be in a good usable condition. Data cleaning helps you identify and remove the errors, remove duplicate data in order to create a more reliable data set. And so it also improves the quality of the training data for analytics that you'll use, and it also enables accurate decision making like throughout the process. So this is an extremely crucial step in machine learning and data science. I'll give you an example. So when I was working with the Swiss project, we were working on some data set that was provided to us by some senior MDs in Switzerland from we were working with. I'm sorry, I got distracted. So we were working with some senior MDs in Switzerland, and we got this data that had like 6,000 rows and 300 columns probably. So we decided to proceed with 11 out of those 300 columns based on initial insights from doctors, that these would probably be the most useful features that we would want to use in this particular model. So now after that, I started working on cleaning the data. So removing columns with duplicates or holes or some values that absolutely made no sense. Like if it's like a categorical value, like if someone's a smoker or non-smoker, it should be 0 or 1. But if the value is like 98, it does not make any sense at all. So cleaning the data. So after cleaning the data, I was left with around 490 rows of data. So from 6,000 to 490. So after this, I worked on filling some of the holes using some techniques like mean, median, mode, or some other ways that I could substitute the data. So this could probably help you understand how much data you would receive in the real world, which is actually garbage and not usable at all. So that's how important data wrangling, data cleaning is in general. So the next is EDA, which is explanatory data analysis. This also involves some sort of business acumen and storytelling aspects. So this is more of where a data analyst's role lies in this third level. So this is where you work on making some sense out of the data, drawing insights from the data that you have, and then communicating the same with management. In simple terms, you work on some visualizations, and that's the most like the core responsibility of a data analyst. So obviously communication plays a huge role here. The next you see is applied statistics and experiment design with mathematics. So, when it comes to data science, statistical methods are a central part of data science, and almost all data science interviews predominantly focus on descriptive and um, inferential analysis of statistics. So, it is nice to have a clear understanding of the underlying statistical and mathematical methods that explain the working of these algorithms before you actually dive into coding and learning these algorithms in general. You don't need to be necessarily a statistics and mathematics wizard, but it's nice to see what's happening behind the scenes to understand where the magic happens and how the magic is happening. So yeah, so I that's a very important aspect if you want to work more in active data science. So then comes the machine learning and AI part, like the machine learning aspects. So this is where you can jump into. I'll just take the first two, the machine learning and deep learning together. So it's where you jump into all those fancy algorithms for machine learning, deep learning. You apply random forests, you apply a naive Bayes model, um, recurrent neural networks. So once you have understood the statistics or the storytelling, the data part, once you know your data the best, that's only when you can actually, even get a good understanding of how to um, apply those machine learning or deep learning complex sophisticated algorithms. So how to improve or learn maths for ML? So there are a couple of good resources. Definitely one course which I would suggest for like a good fundamental understanding of mathematics for ML would be Andrew Ng's course. And then I have a friend. His name is Louis Bochard, and I can send these some links also with along with my presentation to Society of Data Science, and they can probably share it with you. So my friend Louis, he has a website, and he has explained the mathematical aspects really well and curated some resources that would be very helpful. Otherwise, there are some books that I can recommend, or if you are someone who likes to learn visually, then I can suggest some videos as well. What do you prefer? Would you mind writing that in the chat? Okay, so I'll just share some good resources. Okay, so you prefer links and videos and video tutorials. So in that case, there are some good videos which I think Code Academy. There are some good videos from Free Data Camp. I think it's Free Data Camp. And there are some good links also for Free Data Camp. And as the name suggests, it's mostly free. And if someone's like looking for some video tutorials on just the mathematical aspects of machine learning, then Khan Academy makes really good videos for that as well. And you can like look at the mathematical courses for that. And another thing, like for linear algebra, I actually came across a course which was good from Khan Academy, and it speaks about like matrix transformations, EDA aspects, coordinate systems, etc. And one can also look into data camp. There are some exercises and some courses, like short courses, like maybe 3 hours, 4 hours, 5 hours courses based on the topic that you are interested in. So So yeah, if it's like maybe a particular topic that you're interested in, then you could look into that as well. Um, I'll share the links with my presentation. So I'll also share the links of my particular social accounts with the presentation. I also had done some of the blogs some time back, like maybe like 7-8 months back, on all of the basic algorithms initially, and that could also maybe um, help with realizing the mathematical concepts behind the basic machine learning and deep learning algorithms. So someone asked what NLP is. So basically, NLP is when you use, in simple words, if a computer is trying to communicate with humans in their own language, and yeah, if a computer is trying to communicate with a human in our language, in our human's own language, that's something that NLP essentially is, or that's basically what the origin of NLP is. So I'll give you an example. NLP makes it possible for computers to read text, hear speech, interpret the text and speech properly, make sense out of it, make sentiment, and then determine which of those parts that were being told are important. So it's basically a part of a combination of artificial intelligence, computer science, and linguistics in general. So yeah, like in simplest words, that's what NLP is. And there's a lot of work going on in transformers right now, in NLP, which is very interesting. And like if you want to divide NLP into maybe like 5 phases, it would probably start with a more structural analysis of a situation, and then you work on parsing, then semantic analysis, then you work on some sort of discourse integration, and then you do like a pragmatic analysis, which helps you basically interpret and get the results that you would like to achieve. So the next thing that I wanted to discuss probably was, and if you have any questions, um, you can let me know, or you can always type in the chat, because that's obviously my priority here. Um, so yeah, so what do you think is the best approach if you want to get a job or an internship in this domain? Or what do you think is the most important thing? I know a lot of you are like from first to second year, so internship would be more relevant. But honestly, the approach isn't too different, in my opinion, for a job or internship. So, what do you think would be the best, practice or best approach to do so? Or what do you think the interviewers are looking for when they're hiring for any machine learning, deep learning, data science, artificial intelligence roles? Or do you have any questions? Do you have any feedback around that? Okay. So, in order to explain this, I would, yeah, projects and internships are good. So, in order to explain this, I would like to jump a little into the state of artificial intelligence right now. And yeah, so it is very overwhelming to look at, the requirements for jobs and internships. It's often like 15 different things listed. So, so I would like to probably discuss these 4 points when I discuss the state of AI. And I don't really need to share my slides anymore. So, so yeah. So the first thing is that I look at artificial intelligence as an opportunity for both new graduates or students who are new to the field, who have been working for a couple of years, and also for their employers in general. But of course, there's some problems, some challenges that's associated, because there's a lot of competition in the field. Not everyone has had a good amount of solid information during maybe their undergrad or during their engineering. And also, it's a little difficult to get relevant experience in this field. Also, for employers, it's extremely difficult to find people who have the right experience that they're looking for. So it's a problem essentially for both parties in general. So and as you know, as a college student, it is a hard thing to deal with. But I think it also gives a great chance, a great opportunity. A highly desirable candidate, according to me, would be someone who has the right skills, obviously, which means that it is important to stand out a little from the pool of recent graduates, but also from people who have worked in the field before that, preceding you. So, in order to build definitely a good portfolio is important. Networking, showcasing your work, all of that. Good knowledge of statistics, like having a good foundation, all of that is very important. I have an issue. I have one issue that there are a lot of things for beginners, but yeah, that's actually true. And that is a huge problem that like people expect you to do a lot of things, but there are only certain things that you can do by yourself. For example, you can't get the same experience of working in a company without actually working in a company, and it is as true as it can be. So that is why I like to look at it as the classic chicken and egg problem, right? So maybe let's start with experience. So when you think of experience, um, if you want to work for maybe a company that works for ML, that does artificial intelligence or ML or data science, it's hard to get the same. It's very hard to get experience there in the beginning. So if that's not an option, you need to get the experience. You need to do the job. Someplace else, and there are some ways, in my opinion, to do that. The first thing I would highly recommend everyone would be to work on personal projects and putting those personal projects, personal ML data science projects on GitHub. So the first thing, like if you approach a recruiter or if you approach someone else through your personal connection for a role or for a potential role discussion as well. So they would like to actually see what you have been doing. So a CV is good, but if you can give them a little more, which can help them understand why you're different from others, that's extremely important. So I understand that it might be hard to think of what kind of project you want to do while you're still learning machine learning, and that's fine. I think in the beginning, it's nice to experiment with a couple of different domains if you maybe are not sure of what domain is the most interesting to you. Um, because domain knowledge is of extreme importance in machine learning or data science. Based on the quick experiment that we did earlier, if you know more about the field of the problem that you're solving, if I was someone who studied maybe a little bit more of oceans, or if I was someone who knew a little bit better of about the grade of plastics, it would have been easier for me to work on that particular problem. So that's why I think it's good to maybe understand what domain you're interested in and focus building a portfolio in that domain that can help you, separate a little from the pool that's already out there. You can create a niche. So for me, I started working with computational neuroscience in the beginning, and then I translated that work, what I was doing in computational neuroscience, to the climate AI, fintech, green AI aspects. And now I want to stick to this domain because right now I might not be the best artificial intelligence engineer out there. I might not be the best data scientist out there, and I know I'm not. But I know that if you want to, like look at someone who understands carbon sequestration and how to do carbon sequestration using artificial intelligence and data science, that's something that I could probably know better than the other person. So it's nice to have a niche. It's nice to build something that separates you from others. So yeah, when you are maybe beginning your GitHub profile, like beginning to create a good GitHub profile portfolio, um, it doesn't need to be anything like super big or super flashy or extremely innovative. It's nice if it's innovative, but it doesn't necessarily need to be. Don't put a lot of pressure on yourself. It just needs to show that you know what you're doing, you know what you're talking about, and that you can work and you can research on your own, and it will show your coding standards. Or you will definitely not be the best coder when you begin. So showing an improvement is also something that a lot of people look for. So a couple of things that when I started working on my GitHub, I kept in mind was I never used to spend more than a month on any of the projects. Take small projects that you can do preferably quicker. Also, make sure that the code is clean, it's modular, it's well written, it's commented. Very important. Also, the code, if you are ever creating a repository there, make sure you add a README file and any other documentation and give the right credits to the people who maybe have inspired you, or if you have taken a part of the code from them, or if it's a tutorial that you followed. It's a very good practice to give credits to the people when they've done something. Also, if possible, write tests for unit tests for some important parts of the code that you have been working on, some important parts of the code base. What are the profiles freshers are hired in company initially? I don't maybe understand the question. Could you please elaborate on what you're asking a little, Neeta? How important is data structures and algorithms in building a profile in data science? So the thing is that data science and algorithm is it's something that you maybe won't use it every day, but it's something that gives you a good foundation, good understanding of what you're doing. So it is important to know data science and algorithms, definitely. Also, it depends on the type of role that you're looking for, or you are speaking about. If it's a little more software engineering driven role, or a more machine learning engineer role, then I think data science and structures are more used there as opposed to a traditional data science role. So yeah, if it's like more backend, if it's more software engineering driven, then data science DSA would be more um, useful in those roles as opposed to like more statistical or more traditional data science roles. I personally love JavaScript a lot. Can I get into data science and AI domain with? So I mean JavaScript. The problem is that if you work in data science and if you work in AI domain, you'll always work in a team, right? So the thing is that the others, they usually work with Python. Most people. Some problems are done on R. So that is the biggest problem when you talk about using JavaScript in data science. And it does not have essentially dedicated libraries or frameworks that can be used for data science and AI. Is there a better scope of AI ML here in India, or should I target somewhere abroad? There's scope for AI in data science everywhere. It depends on maybe what you're trying to do as well. Because when I was in my undergrad, I was in my final year in 2019, and I was very interested in computational neuroscience, and I didn't know a lot of work that was done here, and I did in Stockholm. So that's the reason I went to Stockholm. So yeah, but there's like a lot of good roles everywhere, and there's a lot of amazing work being done in India as well. If there's maybe a domain that you're interested in, feel free to let me know. And if I know someone in India, I would love to connect them with you, or anyone abroad. And if I know them, I would love to maybe put an introduction. But it's not, a thing about the geographical location. And right now, the thing with pandemic is that even if you have an opportunity in the United States of America, it's very easy to work from here. So that's no problem at all. Is deep interest in the field of statistics also required for data science? I mean, as I said, you don't need to be a wizard in statistics, but it's nice to understand. You may not like love statistics, but you need to, you need to invest times here, and you need to understand it. So, yeah, I mean, I wouldn't say a deep interest, but I would say a good understanding of statistics is important. What roles can a non-IT with 10 years of experience anticipate from data science domains? Oh, um, so what experience are we talking about? The thing is, data science is very competitive, and if even if you come from a IT domain, people, it's like, okay, so how it works is that I know a friend who came from computer science from a decent college in Bangalore, and he started his journey as a software engineer in company A. Then he leaves company A after 2 years of work experience, and then he goes to company B. And right now he's a data analyst. Um, and once he's a data analyst for 2 years or something, or 3 years, and after that he can be promoted as a data scientist. So the thing is that the field of data science is a little more competitive and also a little more overrated. So it also, and now it would depend on what type of non-IT professional experience are we talking about here. Um, if your experience is unfortunately in a different field, then it may not, count too much as an experience if you are transitioning your field directly. So also, how much of current knowledge is there in that particular field? That's also something that's important. That if you are maybe like completely devoting a lot of time focusing on data science and you have a very good understanding, then that definitely helps. But I would still say that it would be very competitive. Can you elaborate the must-have skills for different data science roles? Say a non-CS student is asking. So yeah, as I already shared in the roadmap, there are a couple of roles. There are a couple of skills that would be important. So first off is programming. So at least one language. I prefer Python because it has a lot of frameworks, libraries, etc. Easy to use. It's like English. So first off is programming. Then the person would need some understanding of some scripting language as well, like SQL, for example. A person needs to know GitHub, version control, etc. Then the understanding of machine learning, deep learning, algorithms. Like for example, there are three different types of algorithms, and what are those algorithms, and some basic mathematical formula behind them. So those are important to learn. Then the how you deal with data, how you get data, how you clean data, how you make it ready to use, all those parts are important. So data wrangling, collection, etc. So and yes, like some level of statistical understanding in order to interpret those data. That would probably be the most important skills. Like if you want to narrow it down to the most crucial ones, these would be the skills: programming, understanding of MLDL algorithms, some statistical mathematical foundations, and understanding how to work with data. And I think if you have these skills, then you can at least start an internship, if not a full-time job, and then you can grow on it as you work. So yeah, I hope that helps. uh, so yeah, just a second, I'm so sorry. Yeah, so the next question is, what is wait, let me see. So your Kanak is asking, what is MLOps or data engineer? Recently, there's been a buzz about these profiles. So MLOps is basically, like if you want to. So when you're working with a machine learning problem, you work on deploying the problem, etc. So and then once you deploy the problem in the real world, you need to also maintain the models so that it's like useful after you have deployed it as well. So that's when ML ops necessarily comes into pictures. It's usually some methods or like practices which aims more towards deploying these models and maintaining its reliability, making sure it's efficient and reliable. So that's the whole point of MLOps. It's more of like model operationalization. And MLOps, if you're working with MLOps, it's usually like a collaboration and working with several data scientists and like operation professionals as well. And these practices are often applied to increase the quality, simplify the entire management process, automating the deployment of machine learning models and deep learning models in very large scale production environments. So it targets a lot of scalability as well. So it is one of the best emerging practices or something, and it is extremely important to learn. I'm also not like haven't been working too much with MLOps, but like for the past maybe 1.5 months, I've been trying to find some time to learn more about it and like work a little bit on it if possible. So the next thing you want to ask about is data engineer. So basically, a data engineer usually works with a data scientist. A data engineer, however, is a more you know comes more from a software engineering background as opposed to anything else here that we have discussed. So a data engineer creates and maintains some optimal data pipeline architectures. They work on building some systems for optimal data delivery. They work towards scalability, and they work towards maybe some optimal ETL, the extraction, transformation, and loading part. And they also work towards creating more data tools, which helps data analysts to further build and optimize the products that they have been working on. So it's more towards the data pipeline architecture, optimal system delivery, scalability, those aspects. And they work with database clustering tools, techniques, data modeling techniques, logical operations, um, and yeah, like logical operations, data models, like more of comparative analysis of data stores. And if you're interested in learning more about data engineering, then you must follow Zach Wilson on LinkedIn. And he posts really amazing things about data engineering. And he's been, I think, working as a data engineer for maybe like 5 years or something at this point, or maybe a little more. So, yeah. that could give a very some good insights about that. I would love to share more about my story, or about what I did. So, but yeah, maybe let's first finish the questions that we have here so that they are answered. And if you just want to learn more about me, then we can speak anytime. So that's not a problem. So, so when it comes to NLP, there are like a lot of key application areas or a lot of places where you can use NLP. It's used a lot in like searching specific elements in the text, um, and like conceptual analysis, looking for synonyms, looking for incorrect spellings or some entry errors. It's also used a lot in summarization of texts. So if you have maybe like a 500-page document, you can use NLP to shorten the length of the document, just extracting what's the most important and like useful information out of what you have been given or what you have been working with. It also works with a lot with like how do I like entity extraction, identification problems. So you can extract like some person's name, their information. Like this is something that could be employed by the governments or like the crime departments or something, like verification purpose, etc. Like looking for a certain person or matching a certain person when they have this list of criminals, for example. Another use case could be search engine optimization, customer support, also like some doctor's reports or academic research papers. Actually, a lot of NLP was also used in developing the COVID vaccine, and usually it takes like 12 years to come up with a vaccine, but this time it was done in two, and a lot of the work was done via NLP as well. Also, like if you want to like group information or work more towards text classification, that's also something that NLP has been used a lot for or can be used a lot for. Also automatic speech recognition, which is extremely good when it comes to NLP, although NLP is more traditionally used for text, but it also can be really good for speech inputs. And yeah, like you can basically work towards the speech recognition techniques, like recognizing the error rate in speech, etc., as well using NLP. However, there could be some issues um, uh, in some translation, like speech to text translation. It's not as good as you would want it to be. So there can be some challenge of lack of segmentation in oral documents, and that's probably one of the reasons why it works better with text. But yeah, speech is also a good place where NLP can be employed and has been employed. For someone in environmental sector, what skills and languages would you advise? So, in order to to achieve what in the environmental sector, it would depend on that. So maybe you could get back to me about that, and then we'll discuss that. Some of my favorite data is image data, because I love especially satellite images. It's a little complex, but it's fun, and it can help us analyze a lot more about how much we are ruining the planet and what we need to do in order to make it a little better for us. I also really love healthcare data, and I've worked a lot with healthcare data, and that also involves a lot of governance aspects when you're working with health data, like a lot of governance ethics, which is very interesting for me to work with. So some of my favorite data science communities and forums. So I'm a part of Google Women Developers. Um, so I'm a mentor there right now at the Women Developer Academy. So that's something that I would really, I mean, not exactly women tech makers, but there's GDGs, which are the Google Developer Groups, and they organize different chapters in different universities, different cities, states, etc. So they organize these meetups where the Google developer experts and other distinguished speakers, they are the guests, and so you could like listen to them speak in person, can interact with them. There can be different workshops that's organized, and there's a lot of like open learning in Google developers. So I really like that personally. And right now, I'm the director of AI for diversity, and we are soon going to work towards a lot of events like conferences, hackathons, etc. Definitely in 2022. So that could be something that once we add more active, could be interesting to join. Steve Nori is the founder. He's based out of Australia, and I'm the director for Sweden. And we have some other people like Alex Wang and some others who are working on this initiative. So that could be interesting. The other thing is AI Guild, which is more focused towards. I'm a founding member there, and my friend Tanya, she's the founder, and so they are more focused on linking or the correlation between academia and organizations, like more commercial organizations or corporates, in the field of artificial intelligence. So if that's something that's interesting to a person, then that is an amazing group to join. And often, like if you're in the Slack channel, there's often these job opportunities that, if some other member is looking for some person to work with them or join their research group. So there's a lot of opportunities that's often advertised or shared in the group. So that's an amazing group to join, community to join. If someone's more interested in data governance and understanding the ethics of artificial intelligence, which I think is extremely crucial, then I have a friend, Phil, and he recently started Data QG, and he and so yeah, so that's also very interesting community to join. Like it has a lot of you know ethics and governance specialists right now. And something that I have personally seen in Europe is that for the past 1 year, there has been a lot of focus on the governance, ethics, management aspects of AI data in general. So I think it would be really nice to look into some of that if interested. Um, in real big world projects like neuroscience work, how much time is spent on? Oh, okay. So this is a very, very interesting question. So I'll tell you. I had, when I was going to do my bachelor thesis for the first time, I was going to work for 4 months because that's how long our usual semesters used to be. I don't know how it is right now for you guys in COVID, but I studied at PES in Bangalore, and my semesters used to start from Jan and end in April. So I had 4 month long semesters. So the first time I went to do my thesis, I could not work on real life applications in computational neuroscience because it was not enough for me to get the data and set everything up in that time. So yeah, it takes a very, very long time. It would depend on what nature of data you're talking about and what nature of data you want to deal with. In our case, we would need to collect the data in the first place to work with. So obviously that would take a little longer, but it takes a lot of time in general. Also, the nature of the data is it's not very easily available, so it takes a little longer, lot longer than you would want it to be. So Sachin wants to write algorithms for real world. So what type of algorithms do you want to write? Like, do you maybe have a use case in mind? Is there a particular field that you're interested in, a domain that you want to work with? So yeah, with companies like Meta getting critique for misuse of data and data science being used wide scale, do you think there should be some law body? There should be. There should be, and that's the reason I joined data. I joined Phil's data community also and data governance, and there needs to be. I mean, otherwise it's just not, it's just not fair. And I think if there is no governance, or if there's no data governance body about ethics, like looking after ethics and all that, it very directly affects inclusivity and diversity in tech or in AI in general. So I'll give you an example that actually I was on a panel with some days back, I think on 28th or 29th of Jan. I was on a panel with the director of health and wellness machine learning at Google, and he works in the office of the CTO. And he himself was telling how important it is to, work more towards the governance ethics. And because he is someone who has been working more towards the health and wellness aspect, it's even more important to work with ethics and governance. Um, but yeah, it's extremely important, and people are and organizations are definitely working on it. And yeah, so I was going to give an example of how it affects diversity. So I came across this, not exactly me, but a lot of people would have come across this technology or this text speech recognition, like text to speech, um, speech to text, yeah, speech to text technology. And the model that they built was optimal for people who had long vocal cords and low pitched voices, which essentially meant that the entire model was built for tall men in general. And that's it, like, because you need to have a long vocal cord, um, and then a low pitched voice. So yeah, so the thing is, now when you relate it with ethics, some most times it's like people from, people from the organizations, or people from the communities that are not very included, they most times they don't have the confidence to participate in um, research or in any such surveys, because they're not sure of ethics. They don't have this confidence that about what is being done to the data that they would provide. And it's not their fault, like, there's a huge ambiguity in here which needs to be filled, and hence a lot of work needs to be done. So if they, provide more confidence, then more people would participate. Like, I wouldn't want to give my data, I wouldn't want to give my face to someone where I don't know what they're going to do with it. And if I don't give my data, then I'm not included in the study. So anyways, like 22% female all across the world work in artificial intelligence right now. So you can't really get the data only from the people who are working in this field right now. So that's why it's extremely important to work more in ethics in order to promote inclusivity and diversity as well. I hope it makes sense. Um, yeah. So does anyone have any more questions? Did I? Yeah, does anyone have any more questions?
Thank you, ma'am. For like, I don't think there are any more questions. So we're really grateful.
I think I missed one question about do you ever get data in NoSQL format? I personally haven't. I don't think it's that common, but maybe in some cases I probably won't be the best person to answer that. I haven't received data in NoSQL format. Yeah, sorry, Shivam, go ahead.
Ma'am, that was a really great session. We are really, really thankful for you to take out your time and share your insights with us. Like, I'm sure everyone on the stream took a lot from there, and it will be really helpful. Like, personally, even from my experience getting into data science, AI, and all that, it seemed daunting, but as you start, it gets to unravel really easily. So, yes, thanks a lot for your guidance. We hope to see you again for the next summit. This was really helpful, and we hope to draw more knowledge from you. Thank you.
Definitely. And if anyone's interested in connecting with me on LinkedIn, feel free to do that. I try to reply as soon as possible, but even within a week, I'll definitely reply. So yeah. And if anyone maybe is looking for an internship and needs oh yeah, if you do, you have 5 minutes. There's something that I wanted to mention. So
Definitely.
a lot of people from undergrad universities, they reach out to a random person on LinkedIn. Like I get a lot of those requests. I'm like, and they're like, hey, this is my CV, get me a job. So this is something that I wanted to say, because a lot of people here right now would be looking for internships and jobs. And I personally think getting it from a first degree or second degree connection is a lot more easier as opposed to going out there in the field and getting it. So instead, if you are approaching someone, definitely approach people. It's really good. I approach a lot of people. But the way to approach people is to introduce yourself a little and then just tell them that, hey, this is my interest or this is my expertise. And it would be really amazing, or I would be really grateful if you know someone who's looking for someone with my expertise or something on those terms. And they do not really send your CV right away in most cases. I mean, try to have a little conversation with the person before, try to understand if they can actually help you or not, or like invest a little time in that is what I want to say. And that could definitely be very amazing. And even if it's a cold approach, put the other person in the position of choice. Like tell them that, could you please do it, or I would be very grateful if you do it. And that basically tells the other person that you understand, even if they're not able to help you. Because a lot of times, if I'm not able to help the other person, they start like, hey, so you won't give me a job, you're just here for no good. So yeah, so don't, I mean, just take care of that. And yeah, having a good connection can go a long while. I met some people in 2020, like no, I met some people in like 2019 July, August, and they didn't have some work with them right then. But after like 8 months, they approached me with some very interesting projects, and we worked for like 5 months after 5 months, then like a year after I met them. So having good connections and maintaining good relationships is extremely important, especially in a highly collaborative field and highly innovative, ever-changing field like AI and data science. So yeah, that's it. Are you muted?
Yes. And we'll be sure to add your social media links to the description so everyone can follow you and ask you for more advice in the future. Thank you.
Yeah, definitely. Thank you. It was really amazing. And it was amazing. Everyone was interactive. I'm very happy.